welcome back to Cracking the Cryptic, and just look at this grid. There is so much to talk about in connection with this puzzle. I'm going to start with the pronunciation of the famous Swiss mathematician Leonhard Euler. Now, I say Euler despite the fact that it's spelled E-U-L-E-R, because that is, and Wikipedia confirms this, the pronunciation in Germanic languages of the diphthong EU. They spend euros, and presumably they live in Europe. But Euler would have said his own name as Euler. So although we were streaming the other day and everybody was telling me that it's Euler to rhyme with ruler, well, you can pronounce it like that. You're very welcome to. I am going to choose Euler. And here we have Euler's unbelievable mathematical equation in Sudoku form. So this is clearly saying e to the power of pi times little I plus 1 equals 0. And as you know very well, pi is the circle constant, the relationship between diameter and circumference of a circle. Little I is the imaginary number that by definition its square is equivalent to -1, so it doesn't actually exist, but it makes this formula perfect. Actually, I can't do better than read the explanation that Tobias gave on Logic Masters Germany, where he published this puzzle. Euler's identity has often been described as the most beautiful mathematical equation, he said. It's remarkable that it links mathematical constants from completely different areas. Euler's number e, i.e. the base of the natural logarithm, the circle number pi, and the imaginary unit I, as I described. It's amazing that by linking these quantities in the context of complex exponentiation, a difficult process to understand in itself, you actually get the integer -1 and therefore 0 if you add 1. Even more astonishing and useful, however, is Euler's formula, which is, of course, e to the power of I to ix equals cos x plus I sine x. And I think this identity is a special case of that formula. And that formula, says Tobias, forms the basis for the polar representation of complex numbers and has a wide range of applications across science and technology. Nobel Prize winner Richard Feynman described Euler's formula as the most remarkable formula in mathematics and our jewel. And you can't say fairer than that. Now, I have actually read Feynman on this formula, and I've read a chapter in a wonderful book that I recommend, which I think is called 1069 and all that. I might have, if I remember, and if I've got that name wrong, I will try and correct it in the comments so you can look it up. It's just a little booklet of intriguing mathematical chapters about really interesting things in maths. And I'm not a mathematician, which is why I've probably said something already that mathematicians will go, no, 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 that is not the case. And feel free to add your corrections technically under the grid. Now, what I will also say about this puzzle is it's by Tobias Brixner, who, of course, brought us only a month or two ago the rather incredible Einstein's special theory of relativity puzzle, where Simon had to imagine shrinking spaceships in the grid that expanded in terms of their numbers. That was extraordinary. That was very difficult. We're told this isn't so difficult. This has been recommended to us by a number of people, including most lately Harvey Auerbach. So thank you, Harvey. But you know, once you see this grid, you know you have to feature it on the channel. Look at the depiction of those letters, and it's fairly standard rules as well. I'll go through them in a moment. I don't want to miss the chance to mention that on Patreon on the 1st of November, we've got a new Sudoku hunt coming out, and we urge you to join us to give it a go. No, 1st of December, sorry. We've got this new hunt coming out, and we urge you to sign up in time to have a go at it. It's a matching exercise, I believe. Now, what else have we got going on? We've got, of course, all of our apps featuring line Sudoku amongst them, but most recently Fog of War Sudoku, proving very popular. These are on the links under the video, along with SVEN'S SUDOKU PAD and a link to our merchandise like this wonderful hoodie that I'm wearing. And the first link is to the puzzle called, quite appropriately, The Most Beautiful Mathematical Equation. And I love that Tobias has turned this into puzzle form. Now, also note that the given digits have some relevance. I think the 3 is the most significant digit in pi, clearly, and is sitting on pi. The 1 is appropriately sitting on the 1. I'm not sure about the 6 and what its excuse for getting on the 0 is, but there is probably a perfectly good Euler-based reason for that. Anyway, do give it a try. Apparently not too hard. You can tell from the video length. I'm going to go through the rules now. Normal Sudoku rules apply. That means putting 1 to 9 in every row, every column, and every 3x3 box. 2 cells connected on a green line, that's a German whisper line, quite appropriate as Euler spoke German, must have a difference of at least 5. So you could put 1 and 6 here, or 3 and 8, but not 2 and 6. Each red parity line contains an odd and an even digit. The pink Renban line contains a set of consecutive digits in any order. There's no repeats there. The cell with a grey circle contains an odd digit. Now, is this my only quibble with the representation of this formula? I thought that this little I didn't have a dot on, but I may have missed the point there as well, and I may even be just totally wrong about that. I don't know. I could have made that up. Anyway, do give it a try. I am going to start now. Let's get cracking. So, the things I know, well, I mean, I know loads of things. Okay, I know about Renbans. That's what the purple line is. A set of consecutive digits in any order. There's a 1 on it. So it's got to be 1, 2, 3, 4, 5. And the 3 there tells us where the 3 goes. So that's a nice early digit in the grid. Now, going on to the German whisper lines, the green lines, every 5 can never appear on them. Let's start with that. So the 5 in box 9 is in one of those cells. Oh, the 5 in box 2 can never be on a green line and must be there. Then there's a 5. Oh no, hang on, 5 could be on the circle. Okay, just calm down. Let's go through the things we know. Once 5 is not on them, these digits will alternate between high, low, high, low, high, low, high, low, or the other way around, where high is defined as being over 5 and low as under 5. And finally, 6 and 4 are quite difficult to place on green lines because they only have one possible neighbour. So they can't sit in places like that where they would have 2 neighbours that could not be the same digit. But that 6 is telling us to put in a couple of 1s. It's also telling us about the high-low alternation here, which I might as well fill in as orange and blue. And we can do much the same up here. Never scared to overmark a grid. We don't have any numbers yet on the E or the plus or this little I, but that 3 must be surrounded by 8 and 9. The other cells in the column are 6 and 5. 4 can't sit here because this digit has neighbours that see each other. This digit is the last orange one in the box and is 6 or 7, so that can only be surrounded by 1 and 2. We now know the alternation of polarity or height or lowness on this E green line. Don't worry, maths fans, I will take out the colouring before I finish the puzzle. Now, this is also 6 or 7. Right, this can't be a 6 because it's sitting in between 2 blue digits that have to be 1 and 2. That's now a 4. That has to sit next to 9. This has become 6 and can only sit next to 1. And we are flying through the maths of Euler's equation so far. Now, that is 2, 3, or 4. This one, 1, 2, or 3. This one, 2, 3, can't be 4 because, again, its neighbours see each other. And these are from 7, 8, 9 because they can't be a 6. I'm a bit worried that I'm going to suddenly achieve a sneeze, which will surprise you. Let's hope that doesn't happen. Now, that is 2, 3, or 4 as well. This digit has 4 neighbours. This has to be an extreme 1 or a 9, and we can see 1 sitting there. So that has to be a 9. And these are all lower. They are 1, 2, 3, 4. The 1 is not on in the row where it can't be here either. So actually this is the 1. Should just colour these blue for completeness. And that's coloured everything, oh no, not those two, but almost everything on a green line. Now 9 being there means that is 7 or 8. This also cannot be 7, cannot be 9, not allowed to be 6, oops, in that position. So that's an 8, this can't be 4, that can't be 3, just ordinary Sudoku doing some of the puzzle. 6, 7 pair here rules 7 out of that cell. 7, 1, 2, 9, 3, okay, I don't quite know what else is going on down the middle. This one is, I'm going to leave 7 as a possibility, 7, 8 or 9. Same here. All of these have 2 neighbours that see each other. So they're a 7, 8, 9 triple. 6 has to sit in one of those cells in box 4. And that sorts out the central digit. Now 7, no, nothing about 7, sorry. These digits are 5, 6, 7, 8. I can't colour them orange because 5 doesn't deserve orangeness. Now, can we even attack this? If that is high, it's a 9. In fact, that is 9, 2 or 4. So if this is high, it's 7 or 9. If it's low, well, all of 2, 3 and 4 are options. That's harder to pencil mark, therefore. Now, one of these is a 7 and is surrounded by 1 and 2. Oh, I haven't looked at these. That is 2 or 3, can't be 4 there. Same here. So that's a 2, 3 pair. And all of these cells are in positions where they have 2 neighbours that see each other. So that is a 7, 8, 9 triple as well. And these are a known 4, 5, 6 triple. I'm not really going to tackle the red lines yet because I don't think I've got useful information. This is an odd digit. 3, 5 or 7 are left by Sudoku. That doesn't tell me much here. Or here. Well, I'm going to carry on in my own merry way, pencil marking things just to see if something pops out. 8 in box 3 has to be in one of those 2 positions. Can I use the 7, 8, 9 triple? Yes, one of these is a 7. It's not this one, which is actually sandwiched between a 2 and a 3 in some order. So 7 is in one of those 2 places. That can't be 4 or 6 because of this 4, 5, 6 triple. Now this can't be a 2, 9 pair, which makes things begin to get interesting. Not maybe interesting enough. There is a 6 in one of those 2 cells. Oh, and there is a 5 in one of those 2. No, that's not necessarily true. Okay, ignore the things I'm claiming when they're not right. 4 is somewhere there. Yeah, I don't know. I wonder, I have a feeling we're going to get 4, 9 forced onto this green line, but we certainly haven't got there yet. So that 8 is now looking at that cell. That's happened for a while, actually. That is our 7. The 7 in this box has to be surrounded by 1 and 2. So now we know which way round they go. Actually, this was more straightforward. I was missing stuff there. This is now 3 or 4. That's 2 or 3. Any more interesting Sudoku to do? 2. 2, oh, that can't be 2. 2 in box 5 is definitely there. Okay, I am going to get rid of all the colouring now because it's not really adding anything. We might as well admire Euler's identity. 1, 6, 2, 7. There's a 3 in one of these cells. Not very useful. 7, 2 pair, 7, 2 pair. That's going to put a 7-2 pair somewhere here. And this has to be 3, 4 or 5 accordingly. 1 of 8 or 9 is featured here. These are from 7, 8, 9. And that one can't be 9, so it's part of a 7, 8 pair. We've also got a 2, 3, 4 triple in this row. So the other two cells are 5 and 6, which make them obey the red line, even though I haven't had to think about that at all. Now, whatever that is not in these cells. So one of those is a 4, and that means that is a 2 by Sudoku. And now we've got a 3, 4 pair flanking this 9, and that's a 2, and that's a 3. The 3 in this box has to be surrounded by 8 and 9, then I can fill in the 7. That 7 can come out of these cells. The 9, oh, the 9 wasn't in those. That has become a 7, however. This is therefore now 8, and that's 9. We haven't broken the whispers yet. Now, 3, so there's a 9 there by Sudoku in box 8. This red line requires that to be the other parity, so that is 4 or 6. 2 cannot be there. 2 on the pink line is here. We're using all the lines, one after the other. One of these 2's a 4. That's not such interesting information. How about this column then? No. Oh, this pair. 3 has come off the line. Still not done. 3 comes out of that circle as well. That dot or tittle is a 5 or a 7. This row I haven't really focused on. 3, 4, 5, 8 to place. No, I don't know. This is 4, 5 or 6 in the box. 6 must be in one of those 2 cells. Not interesting. 8 is in one of those 2. Also not very interesting. That can't be 9 anymore. Or 2, actually. That is 4 or 6. Which are the digits I'm trying to allow to feature in row 2. Three, 4, 5, 6 still to place in box 4. Ah, getting a bit stuck now. Oh, I haven't considered this. That is high. So it's not 6 based on those, and it's not 9 based on that. It is 7 or 8. Have I not done anything with 8? I had an 8 pencil mark up here. Oh, 8 is in one of those 2, so that doesn't necessarily help. However, now there's only one place for 1 to go in box 3, and that looks like it does help a bit. That gives us a 2, that gives us a 3, that gives us a 4 down there. Now there's a 3 in one of those 2 cells. 7, 8, 3. This is 4 or 5. This is 5 or 6. Haven't managed. Oh, 3 in the top row is in the corner. That's 3 in the corner, proving not only its own position but also those of 6 and 8 in the box. And 4, 5, 8 to come here. I think we're on a roll. That can't be 8 because of this. That pair says this can't be 8. So I get to place 8 in the final row. The others are a 5, 4 pair. That's reduced 2, 7 to a pair of cells. 4, 9, 1, 8, 3. So from 2, 5, 6, 7 here. Three, 4, 5, 8. Not quite sure what's going on. I haven't finished off this. Can't do these 8s. Let's try this column again. 6, 1, 8, 3. This is 4, 5 or 9. Now, if that was 7, I think something might break then. That would be 2. This would have to be a 4, 9 pair, and that would be 5. If this is 5, then that is 4 or 9, and this can't be a 4, 9 pair, and must have a 2 on it. And that doesn't actually advance us. Interesting. 3, 4, 5, or 6. This can't be 6 anymore. Or 4 in the column, I see. So that's a 2-9 pair, and this is 4, and it is 4-9 on this last. Well, on the green I suppose that should be described at. And that finishes column 8. It finishes box 3. I think the whole puzzle could be yielding to us now. Well done for sticking with me through this. That's a 3. That doesn't fix the wisp, but that's a 5. And that fixes the Renban entirely. Now we are progressing nicely. I think that has to be a 4, and that's a 6, yes. 3 and 8 in the last 6 columns all done. That's a 5. This is a 4-6 pair. I do not know the order, I don't think. That 5 gets ruled out of these cells. Oh, and 5 has also got ruled out of there. So I can put 5 there, 7 in the corner. One of these is a 5. It's not that one. That's a 4. That's a 5. 6 and 4 up this column now. That's a 7 to complete the row. That's a 6. And then we can finish off column 3. And then we've just got column 1 to do. And it completes like this. And there we go. A most beautiful mathematical equation. Such a brilliant depiction. Not that difficult a puzzle. And thoroughly enjoyable Sudoku is the result. So it's a special case of the most beautiful mathematical equation. And we say Danke to Tobias. I've probably pronounced his name wrong as well. But that's a lovely, lovely effort. And thanks to Harvey for recommending it recently. We will see you again soon on the channel. Thank you for watching. Bye for now.